Also, I'm recording. Um, that way, anyone who's not here can watch it back. Okay. Yeah, if no one has any more questions, I'll just get into it. And yeah, again, like feel free to interrupt me at any point. Happy to help. Okay. So share my screen. And I'll turn off notifications, do not disturb. And okay. Can everyone see my screen?
Yes.
Cool. For some reason, I can't see all of your faces now. I don't know why. Oh, there it is. Okay. Okay. Um, cool. So I'm gonna start with the slides. So we're gonna talk about fetch, and I'm just gonna explain kind of what fetch is, what an API is. I have an agenda slide, so yeah, these are the main topics. We're gonna cover fetch, what is an API, asynchronous JavaScript, and JSON. Uh, you don't really need to know much about JSON, but that's kind of uh, correlated. So, um, okay. So the first thing to understand is so far we've been writing code for um, like a website. So we're writing HTML, CSS, and JavaScript. And those are the three languages that like a browser understands, a web browser. So a website, what it really is it's a combination of those three languages or just one or yeah, those are the three languages that like a web browser knows. And it also knows like WebAssembly, but we won't get into that. Um, so that's pretty much what a website is. We've been building it using HTML, CSS, and JavaScript. And that could be considered the front end. That is code that runs on like if you go to a website, your computer is grabbing that code from like a web server. So there's a computer out there that your computer interacts with, and when you type in a URL, you're getting that code sent from that web server to your computer through your web browser, and then your web browser renders the page and the HTML, CSS, and JavaScript. So that is how a front end, like a website or a web app, works. Um, and that's what we've been doing. Now, there's this other concept called the backend, and the backend is what makes the internet possible. It's what makes it possible for our computers to kind of interact with each other. And what the backend is it's code that runs on servers. And so a server is any computer that isn't like um, your laptop or your desktop computer or your phone. It's usually in like a database or a data center. So there will be like a giant building of servers, and there's web servers, and some servers are hosting databases on them. And basically, there are different applications that run on these servers that interact with the front end. And today we're going to be using fetch. And what fetch does is it allows you to have your JavaScript in a website that's running on your computer interact with the backend. Uh, so any server, any web server over the internet. So far, all of our code has only been running on your computer in your web browser. And now we're going to have JavaScript kind of extend into the internet. And actually, like in your code, you can have um, your code ask your computer to reach out into the internet, grab some data, like from a database, and then receive some information back from that server, and then display it on your web page. So we're going to do that with the GitHub API today. So yeah, fetch can be summed up as a JavaScript utility for talking to servers. So it's a keyword in JavaScript, you actually write fetch and you pass in a URL. And I'll get into more of the details, but that's what fetch allows you to do. It allows you to talk to other computers through JavaScript. And this is how it looks. So you write fetch, it's a function, and it's just available in the like global scope of JavaScript. So you can just write it anywhere. It's not like attached to any other thing. It's part of every browser. Um, and then you pass in, so it's a function you're calling, and you pass in a single argument. You can pass in two, but today we're just going to be doing a what's called a GET request. So we're just going to be getting data from a server. And what it takes in is a string that has a URL. And so in here, I just have like a sample URL, https://someserver.com. So that's what a URL is. And so we're basically pointing fetch to a specific server in the world, and that server is identified through a URL. And um, everyone's seen URLs, but you might, as you start learning more about JavaScript and fetch and just programming in general, websites, you'll learn about kind of what a URL really is. Um, it has different parts and they all mean things. But for today, all we really need to know is that GitHub has a URL that we can use to interact with uh, their like database. And we're going to get that URL from GitHub and use that as the string in our fetch. And then we can get your list of repositories, like your personal list of projects from GitHub and display it on your website. So the URL is really what matters here. Um, okay, the term API, it's kind of confusing. It means a lot of different things. It can be used in different contexts. So, um, kind of it's like an umbrella term that has a lot of different, it's used in a lot of different cases. And so, at the kind of base level, an API is application programming interface. Um, and the kind of key word here is interface. An interface is something that allows something to interact with another thing. So like, I guess I could unplug this here. I used to make music a lot and I have an audio interface. That's what this is. So what it is it has buttons and knobs and stuff, and it runs like a music signal through it, and that goes into my speakers. And my laptop isn't like designed to have a fancy like sound card like that. And so an audio interface allows you to kind of interface with the audio signal. So it usually is some device that has like controls on it in the real world. Um, and in programming, an interface is one piece of code that interacts with another piece of code. So it's kind of the convergence of two pieces of code or two pieces of software. It's like the way that they interact together. And it's like the figurative buttons and knobs that are available. Um, and I guess like abstraction is an important piece of that, where, if you're using some code that is available to you through like a library or something, they'll have specific pieces of it that are abstracted out. So you don't have to worry about the implementation details. You can actually just like Google has an API for a Google map, and you can put a Google map in your website, and you don't have to like create the map from scratch because that would be really hard. So they have a specific set of tools that allow you to do that. Um, so an API, it simplifies like interacting with some piece of code. Um, and yeah, so there's kind of two common ways that it's used. One is you're using an existing library within your code base. So you could like take some code that someone else has written and they package it up into a library and then you're using that code in your app just locally. But another way that an API is used is a server out there in the world is allowing other computers to interact with it through the internet. And so an API can be that's the way that we're going to use it today is we're going to use GitHub's API. And it's basically like the layer of their software that allows us to interact with their database. We can't interact directly with GitHub's databases because that would be bad for them. We could delete whatever we wanted, or there's no like permissions in place there. So whenever an application has a database, they always will have an API that kind of interacts with the database for you so that your front end, like the front end is code that's running on the client's device, so a phone or a computer or something. Um, the the front end isn't going to interact directly with the database. It's going to interact with an API. And so the API, um, it'll be different for every company or every application. So a lot of like Airtable has an API. Google has one, or a bunch probably. Even OpenAI, which that's the company that makes ChatGPT, they have their own API. And so you can actually send like ChatGPT requests to their backend straight from your application. Um, so you don't have to go through the ChatGPT interface if you want. You can use their API. So that's what it is it's a server running an application that has certain ways of interacting with it, usually through URLs. So that's how we're going to be interacting with GitHub's API is through URLs. And yeah, it abstracts away some complexity to make your life easier. Um, and kind of an analogy there is a car. So when you're driving a car, you're controlling the wheels, the engine, all sorts of different things, but you're not directly controlling them. You're controlling them through a limited set of controls. So you have the steering wheel and the gear shifter and the pedals, and they're kind of abstracting a lot of the complexity so that you don't have to worry about all that complexity. You just deal with the specific things that they make available to you. And so um, it's an interface. So interface is like an easier, simplified way of interacting with something where they can control. And so uh, like in the case today, we're going to be interacting with GitHub's database through their API, through their interface. So yeah, there's kind of two main types of APIs that you'll hear about. There's libraries. So like fetch is actually an API. You'll hear people say the fetch API. And uh, fetch is actually code that exists on your computer. Every web browser has an implementation of fetch. And the reason that's called an API is because the actual way that your computer like goes out and interacts over the internet, that complexity, there's a lot going on behind the scenes there, but all you have to worry about is fetch. You just have to worry about this simple method or function that they give to you that you can use. You don't have to worry about any of the other stuff. The DOM is the same thing. The document object model, you get to interact with, your HTML web page, and your browser, like, or the JavaScript spec has like a specific limited set of things that you can do, and that's called their API. In React, if you go on to take the React course here, React is when you want to learn React, you look up the React API documentation. Um, and then the other type of APIs are servers. So the Google Maps server, there's an API that you can use, OpenAI and GitHub. And uh, I might as well really quick. I could show you OpenAI API. If you look that up, Yeah, so they have the developer platform. So any developer who wants to make an application and use like AI in their app, they can go to the OpenAI API, kind of a mouthful. Um, and it'll give you code examples, how to use uh, ChatGPT, make your first API request. And they're probably going to be using Fetch if they have it available for JavaScript. Oh, actually, they probably have their own SDK, which is yeah, SDK. That's a software development kit. And so that'll include a bunch of fancy stuff that makes it easier. Um, but yeah, that's API. It's a big one. And I know I'm talking like conceptual high level here. I'll get into actual like down to earth coding stuff, but I think it's good to know kind of what's actually going on at a high level once we start getting into the code. Okay, the last, or maybe not the last thing, but next is synchronous and asynchronous code. So um, so far, all we've been doing is synchronous code, which is code that, so synchronous means like at the same time. So uh, I guess it's kind of a misnomer because your code isn't actually running all at the same time. It runs one line after the next. But what it kind of means is like when you run your application, all the code should run consecutively, one thing after the next. And that is how we have been learning to program. That's what your intuition should be at this point, is that when you're writing code, at least in JavaScript, if you write console.log howdy, you'll see in the console howdy. And if on the next line you write hello, you'll see hello. So these are logged to the console one at a time, one after the other, because that's how your code executes, one thing after the next until the application's over. Asynchronous code kind of breaks all that, and it can kind of be confusing because of that. So asynchronous code is some code that waits for an external task to complete. So if you're hopefully making the connection here that when you want your code to interact with a server over the internet, your code in the like execution of your code, it's going to have to wait for your computer to send that request over the internet and for another computer out there, the server, to respond. And it doesn't take very much time. It takes like 5, 10 milliseconds usually for an API request over the internet to go through. It depends on like what it is, where you are, what your internet speed is like, and all that. But um, if you were to write your code in a synchronous way, um, there would be no way to have one line of code wait until the server responds and then keep going. You have to use asynchronous code. So we're going to wait for an external task to complete, and that external task is the response from the server. And so this is not, you won't be writing a timeout, but this is kind of the simplest version of asynchronous code. Uh, Set timeout, this is available. This is just like a JavaScript thing. You can write set timeout. It's a function that's built in. And the syntax looks kind of weird, but again, this is a callback, which uh, callbacks, I'll try to explain them a bit more when we go into fetch, but it's taking this function, this arrow function as an argument, and then the second argument in set timeout is a time in milliseconds. And what this is saying is wait 10 milliseconds. So whatever you pass in here, it'll wait that many milliseconds, and then it'll run any code that's in here. So the result of this is we have this set timeout, and then console.log is being passed in, and it's saying wait 10 seconds before you run this. And then on the next line, we have console.log hello. And what that will show up in the console looking like is howdy, even though it is on this top line here, it shows up on the bottom line in the console. So hello, this line actually executes before this line. And the reason is because we told JavaScript, or we told your browser to wait 10 seconds before or 10 milliseconds before executing console.log howdy. And so it'll run this bottom line first and then the top line. So it's kind of weird, but that's asynchronous code. It doesn't happen in order like you'd think, because some code has to wait for another thing. So it's essential for fetch because your code has to wait for the server to respond over the internet with the data that you need. Now, there's two common syntaxes that you'll see for asynchronous code. One of them is the async and await syntax, and then one of them is the .then syntax. So these are kind of like, they make sense if you've seen the evolution of JavaScript. I wasn't around like writing code when people use .then more often. Uh, I learned through async and await. But these are two different syntaxes that achieve the same thing. They're a way of dealing with asynchronous code. So today we're going to be using the .then syntax. But basically what they are is two different ways of making your code wait for some other thing to happen. So some asynchronous code executes and you want to wait for that task to finish. You can use either async or await or .then. And hopefully the names kind of make sense. Await is kind of like wait. So we're saying wait for the fetch to like resolve. And so fetch itself is asynchronous. Fetch will take some time. And if you don't await it, then your code won't work right. So anytime you use fetch, you have to either await it or do this .then thing. And today we're going to be doing .then. So .then is kind of the old way of doing it. I think async and await are kind of a little bit easier, but we're going to be using .then just because that's what the lesson asks for. They're both pretty common, but .then, the syntax is we're saying fetch, and then when the fetch resolves, we're gonna .then do some other thing. And this .then here, it can be put on anything that is a promise. So fetch or anything that returns a promise. So a promise, we're not going to get into it, but a promise is what's actually happening under the hood. But I know I'm throwing a lot of keywords out there, so just don't worry about promises. Anything that is asynchronous uses promises, and .then or await are the two ways of interacting with it. We're going to be using .then. And .then, what we do is we say .then, and then in the parentheses here, we're going to pass in a callback function that has a bunch of code that's going to like any code that we write in this .then is going to have the result of the fetch. It will be ran once the fetch concludes. If we were to try to use anything that came back from the server without .then or awaiting it, then we wouldn't be able to. We can't. So, okay. Last kind of big topic is JSON. We don't actually interact directly with JSON right now. We are kind of. Basically, JSON is a format of, it's like a programming language you can think of. You can think of it like that. What it stands for is JavaScript Object Notation. So JSON, JavaScript Object Notation. And it's like just a format for data that looks like a JavaScript object. And it's the syntax used for transferring data over the internet for the most part. So when we get our like data back from like whenever you use fetch, usually what you're going to get back in your JavaScript is a JSON, a piece of JSON data. And that data needs to be parsed and turned into a JavaScript object. And because like GitHub, their servers are set up to send you JSON, we can easily interact with it like as if it's just JavaScript. And the nice thing about that is we could write Python code or C++ or Ruby or Rust, or we could write any language. And as long as the server is returning JSON, that language will have a way of converting that JSON object into the native kind of object in that language. So Python has a way of dealing with JSON, turning it into a Python object, and the same for all different languages. So it's just the common format that data is transferred in. And we're going to see a couple keywords that are going to, the code is going to look confusing today. Unfortunately, that's just, uh, it's kind of a lot. And so uh, understanding kind of all these things at a high level, I'm not expecting you to remember all this stuff, but just at a high level, conceptually, hopefully you'll understand what the code is actually doing. So yeah, JSON is just the format that the data is going to be sent to us from GitHub and from most APIs. And it's just a convenient way of storing data. Once you see it, you'll like it. Um, so what's going on is this is GitHub servers. They're going to send some JSON data that has your GitHub projects, just a list of your projects. And then we're going to interact with those projects in your JavaScript, and we're going to create HTML elements, DOM elements out of those projects. And you're going to actually be able to display your projects from GitHub on your website without having to like manually go to GitHub. And I mean, at the end of the day, it would be way easier for you probably to just go and copy and paste the names of your projects from GitHub. But the cool thing about doing it this way is, well, the main thing is we're learning how to do this, which this is how most applications are going to have some form of interacting between a front end and a back end. And this is the basics of it. Okay, so JSON is basically a JavaScript object. So this is JavaScript right here. This should look familiar. Const dog, it's an object, equals, and then what makes it an object is we're using these curly brackets, curly braces, and an object is made out of properties with values. So this dog has a name of Fido and an age of 2. These are key value pairs. That's what an object has. JSON, this is how that same object would be represented. It looks very similar. It's curly braces and then property or key and value. There's a couple differences. One, in JSON, use we don't store things in variables. The whole thing is just there's like this kind of parent object that everything is inside of, and everything is just objects within objects or like specific like primitive values. So like 2 and Fido, a string. And everything has to have quotes in JSON. So that's all that is. You don't actually have to write JSON today. Okay, so just to recap, today we're doing fetch, which is a function in JavaScript that allows you to interact with other servers and stuff. We're going to use it to get your projects from GitHub. We're just going to get like the raw data that GitHub sends you back, which they decide what they want to send back to you. And they send you each project in like an array, and kind of it's an array of objects, and there's probably a bunch of objects nested within those. It has all sorts of data. Most of the data that you're going to get back is not what you want. And that's just typical. Like a server will send back usually a lot of data, and you'll kind of have to parse through it grabbing out the pieces of it that you actually want. So we're gonna get this gigantic blob of data from GitHub that has your projects. We're gonna have to like parse it out, get the names of your projects and other stuff. Uh, okay, an API is an application programming interface. It's just a big catch-all term for a bunch of things, but in the case that we're using it today, it's referring to a server that you can interact with through your code. So any server that is like set up to send back a response, um, actually all servers send back a response. That's what's in the name. Um, they serve data to another application. So that's what an API is. It's an application running on a computer that is ready to send you some data when you send it a request through your computer. Um, Async, that's shorthand for asynchronous, and it's also a keyword in JavaScript, async. Um, Asynchronous code is code that waits for something to happen. And so here we're using it to wait for the response from GitHub and then filter through the response and stuff. JSON is the format that data gets sent over the internet usually. And in this case, we're going to receive a big JSON object that has your projects from GitHub. Okay. Oh, wait, I had one more slide. That's code. Okay. How's everyone feeling? I just talked a lot. Any questions?
Is there a difference between web APIs and just API? Like, you know what I mean? Like web API and API?
Hmm. Um,
Or is just the name? Like,
I don't know. I guess like a web API. I haven't like heard the term web API used that often. I guess it probably means the same thing. I could imagine it's just the same thing.
mm,
Um, there are different types of applications, and so some of them might cater towards the web and some of them might not. Like a game server,
mm,
for like multiplayer online games, those
mm,
will probably have like a server, or they have a server that's kind of syncing up the information between all the people online, and they'll have an API, but that's not available over the web, over the like traditional internet usually.
mm.
Um, yeah. Okay, so yeah, we're gonna get into actually writing some code now. Okay, so I have, let's see how set up I am here. Um, yeah, this is good. Okay, so we have this. This is I made this project a while back. This is one that when I was a mentor here, I was having students follow along with as I was doing it. But this is my BMO homepage. BMO is a character in Adventure Time. And yeah, we're building a website for BMO. This is the portfolio project, same type of thing that y'all have been doing. So I have some HTML. This is if you're all caught up, this is similar to how it should look. You are supposed to have, I think, more sections and stuff, but um, I kind of cut things out so that we can uh, not overcomplicate it. I just want to, let's see. Yeah. Yeah. So here, just to keep it simple, I only have the projects section. So the project section is important in your HTML. This is what we're gonna like. So the last couple assignments, we were doing JavaScript stuff, which was basically we're making new elements in JavaScript and adding them to your HTML. So uh, you should have some experience with that by now. creating and manipulating elements in like HTML elements in your JavaScript. And so today we're going to be doing that, but we're going to be making elements out of uh, this list of projects that we get back from GitHub. We're going to make some elements with the data from those projects, and we're going to put them in here using JavaScript. So it's important here, and yeah, that's all. Okay, so I'm just gonna skip to the coding assignment and just get to it. So today there's two projects they want you to pay attention to and start. There's the portfolio completion, and then the Open API project begins. So I'm just going to be doing this part, the portfolio completion. For this part, Open API project, uh, you're going to start a new project today, I know, but um, you're going to make a new GitHub project or a new like repository on GitHub, and you don't have to do any coding for this week. You just have to make the empty project and get ready for next week when you actually start. You're going to make a specific project where the whole point of it is interacting with an API. And there's all these different APIs out there. They have a weather API, it's a free weather API. And usually on these APIs, they do tell you to some degree how to use them on their website, API docs. Um, and there's this, I like this one, the dog API, and there's also a cat API. So we're not going to be doing that this week, but you should read through this and start a new GitHub project. Follow that. But today we're going to be just doing this, the portfolio completion part. So I'm gonna not go through the GitHub stuff because I just pulled up this project randomly, and I think the state that it's in is not exactly in line with um, like GitHub wise and Git wise. I think it would, I don't know. I don't have any pull requests or anything, basically. So coding, that's what we're getting to. So we're gonna start with, and maybe sorry, I'll zoom in. It's a little easier to see. Okay, so the first step is we're going to be creating our fetch. So open our index.js, our JavaScript file, and starting below the code from the previous lesson, do some things. So I don't have any code from the previous lesson. I'm just going to keep it bare bones in my project. And again, uh, your project should look something like this. Actually, I think my JavaScript file is supposed to be in a folder called JS. I can't remember. I think it is. And if I put my JavaScript file in a new folder, then it's going to break the link in here. And so I'm going to have to relink it. So js/index.js. And I think your script tag is probably at the bottom like that. That works too. I have it at the top because I'm using this special word called defer, which means it waits until the rest of the web page is loaded. And that way you can have it at the top. That's the way that I prefer it. So I'm going to do it that way. Okay, so we have our JavaScript file, and I'm just going to console log hello world because I just want to make sure that my JavaScript is running right. And I'm also going to turn off uh, completions. Okay, console.log hello world, and let's make sure that that's showing up in my console. Yep. Hello world. Cool. So hello world is like the classic, like my computer is, it's like testing out that you have everything set up right. And you'll see that like a hello world application exists from like the very basics of learning to code all the way up until you are making like really complex applications with tons of different things. You'll usually start with a hello world, which just is like, is everything working right? So this is our hello world. We know that that's working. I don't know what happened to my code. There it is. Okay, so first step, using the fetch API, create a GET request to this URL, where GitHub username right here is your username for your GitHub account. Okay, so, and hint, use the fetch function, and get is the default method for fetch. So what it's basically saying there is uh, fetch is using something called HTTP, which you've seen it in any like URL. A URL always starts with HTTP or HTTPS. That's the language that requests over the internet usually are in. This language, it's like a protocol called HTTP, and you'll actually like eventually learn it. It is part of doing more advanced things with fetch. But today, all you need to know is that fetch is using HTTP and it's using the GET type of HTTP. There's different types of requests you can do through HTTP. There's GET, which is for getting information. There's POST, which is for sending information. So like if you made a Facebook post, you'd want to do a POST request, which means we'd have to change the way that fetch works by passing in a different option. But because a GET request is the default in fetch, which you'd have to you couldn't know this just from looking at fetch. You'd want to like read up on it. But fetch could take in this like different options thing. Um, it could take in a first argument that's the URL, and then it could also take in a second argument. Let me just so it could take in a second argument that's an object where you could say method equals post or get or whatever. But today we're just doing a GET request and that's the default. So we don't have to add a second option in there. So all we're doing is using the fetch request with a normal URL. I'm probably confusing you by going into that. Basically, just ignore most of this. We're just going to be putting in a URL into fetch. So I'm going to copy this, paste it into here. It's going to look like that. And we need to replace GitHub username with your GitHub username. And so I can find that by going to GitHub. I think I have GitHub open. So you can see it up here. There's a bunch of different places you can see it on GitHub, but for me, mine is Rio Redwoods. Another way to go, you can go to your profile and it should say it up here as the last thing in the URL there. And right here, should be everywhere, your GitHub username. So copy that. And in here where it says GitHub username, replace that with your username. And get rid of these curly braces. Those are just there to represent, like, replace that with whatever. So this is how it should look. And what this is now is this is a URL that the fetch is gonna go, it's gonna direct fetch to go to a specific server, which is GitHub servers, and go to your profile within their servers and get your repositories. And so that's the first step. We should have that URL right, and we're not going to know right away. Like if I were to look at my web page, nothing would change. Console, nothing changes. So we're going to know whether we did this part right and like the next step or two. Okay, so the next one, chain a then method to your fetch call and pass it a function that returns the response JSON data. Okay, there's a lot packed into this instruction here. Maybe I'll just copy that. So maybe I could turn line wrapping on. How do I do that? I don't know how to turn. I usually have line wrapping turned off, so just gonna put it off. Okay, so chain a then method. So when you chain something, that means you're calling one function and then you're calling another function using the dot operator afterwards. That's chaining something. So it's this function is executing, and then whatever this returns, we can actually, so we could, the way we might normally do this is say like const my variable equals the result of calling this function. So what we're doing here is we're storing the return of this function in a variable. But instead of doing that, because this whole thing, we can think of this whole thing as like resolving into a single value. When it resolves into that value, instead of storing it in a variable, we can actually just directly interact with it. So whatever this resolves as, we can, if it is if it is a thing that has methods on it or properties on it, um, like an object, if it's an object, then we can add methods to it. And so we know that fetch returns a promise. So eventually this will be a promise, and a promise has a property called then on it. And this is what allows us to do the asynchronous stuff. So we do dot then, and so that's chaining a dot then. Uh, chain a then method to your fetch call and pass it a function that returns your response JSON data. So we're passing a function into this then right here, an arrow function. And just get ready because it's going to continue getting more crazy with the syntax. It's just how it is. Um, so this is going to resolve into a promise that has our data, but we can't directly interact with the data. We have to wait for it. So we do dot then, which means in this dot then we can interact with the data, but we actually dot then, the way it works is it always, so dot then is a function that takes a callback function, which means when you're done doing whatever you do, dot then, call this function that we pass in. And so it's going to call this arrow function, which an arrow function is just a convenient way of making a function inline. So we're passing in an arrow function into the dot then. And then inside the body of this arrow function, I'm just going to put my cursor in these curly braces and then press enter. And that's what it does. So we're now in the body of this callback function. So dot then is going to execute and then call some code. And I could say console.log hello. Delete the hello world up there. So we should see console.log hello show up, or the hello. And there it is. So the the difference between writing this console.log hello here and here is here we have the context of this fetch like returning. Like this will only run, this hello here, this will only run once our computer has sent a request to this URL, gotten the response back, and yeah. So this is gonna wait. If I were to do console log hello there, and then like I could do like 1, 2, and we should expect to see 2, 1. So this is running first, then this. They're running out of order. And the reason is because this in here is waiting until the GitHub server responds. And because we're waiting for it to respond, we can actually get the data that comes back from it. And the way to get back that data is we have to put something in the dot then. The dot then callback we can pass in an actual parameter into the dot then callback function. So the syntax is getting kind of crazy, but that's just the way it goes. So we're going to call this res, stands for response. I could just type it out. It doesn't matter what you call this. It's a function that we're creating on the spot that then is calling, and then we'll pass in the response into this parameter. And then in the body of this function that we're passing in, we can do anything we want to that response. Response as in the GitHub, like the return from GitHub servers, which has our projects. So this response, this will have our projects from GitHub's servers. Our projects will exist in this variable right here. And you usually see this called res. You pretty much always see it called res, which is programmer shorthand for response. And I kind of lied. This is not the projects from GitHub servers. This is the response from GitHub. We have to do one more step to get the actual data, and that is converting it from JSON into like the raw data. So we're going to do one more step, which is so pass it a function that returns the response JSON data. So we're passing a function into then, and this function should return the response, but we're not just going to return the response, we're going to return response dot JSON. JSON is a method that exists on the response object that converts it into normal JavaScript. And even though it's saying .json, it's not converting it to JSON, it's converting it from JSON, which is kind of confusing. Okay. So we're doing that. Now there's another thing we have to do. And let me just, I do have a version of the code that I already wrote, so I'm gonna just double check with it. This is what it's gonna end up looking if you want a sneak peek. It's gonna end up being like this. So this is error handling. I'm not gonna worry about error handling until a later step. I'm just gonna do this. We have return response.json, and then we're doing this other crazy thing where we now do, we do another dot then. So at the end of everything, we're doing another dot then. This dot then, just like with the other one, returns a function, a callback function. And I'm going to save, and I have prettier, which is I have an extension for VS Code called prettier, which if you don't have, you should 100% get it. Like write it down, get this immediately because it formats your code for you. So you don't have to worry about spacing everything out right. It'll automatically format everything for you. So that's what just happened there. I saved and then my formatter triggered. Okay. So the syntax changed a little bit, but it didn't actually change anything. It just put the dot then down here. This is doing the same thing. So this is a kind of more readable way to see this code, even though it's still confusing. But so we have fetch. When we get the response, we do dot then. We return the response.json, which converts it from JSON into a JavaScript object. And then there's one last step, uh, or one last like piece to get the actual data out of it, which is taking, so in here, this dot then has, we're passing in res, and then in the body, we use res, the response. Here, we're passing in data, and now we can use the data. And right here, if I console.log the data, this data should be the response converted into JavaScript and a JavaScript object. So this, we should expect to see now my actual GitHub projects appearing. And it's going to look crazy because that's just, yeah, this is it. So it's returning an array of 30 objects. That's what this is showing. So I can click the drop down and we can see each one of these. This is an object that GitHub returned that is one of my projects. And I have a bunch of different projects on GitHub. So it's going to show all of them. For you, it'll likely be like one or two, depending on how many projects you have on GitHub. So these are the projects that GitHub returned. These are all my projects. And each one of them has a bunch of things on it. And a lot of it is stuff that we don't really care about. So what we're going to do now is we're going to parse this big response and just get out the pieces of information that we want from each project. So we're getting the data back, and then we're going to do a for loop because remember the data we're getting back is this big array of projects. And when you have an array, arrays go hand in hand with loops because loops like to iterate over things and arrays are things to be iterated over. So we're going to use a for loop and iterate over this array of projects and get out just the information we need and create HTML elements out of it. And actually just, I might want to, I feel like I should back up and just make sure I'm following this in order. Okay, so handle your JSON data. So we did this. Handle your JSON data, chain another method. So we did that, pass another callback function that returns, or to parse the response and store it in a variable named repositories. Okay, yeah, that's JSON.parse. I think that, let me see how they're doing this here. Oh, they're using, okay, so they're using the try catch or the async and await syntax here. Async and await. Okay, here's the dot then syntax that they're using. So this is kind of the format or the syntax that we're following. So we do response.json, get the data. I think we don't need to do, I think they might have added something on accident. I don't think we have to do JSON.parse this dot response. We'll find out soon if I'm wrong, but I think data itself is good to go. So we don't have to do that. So console.log the value of repositories to better see the data returned from your API fetch. So we did that. They're calling it repositories. I called it data here. We could call this repositories, right? Like this. And then we could console.log it. Repositories. This is a trick right here, by the way. If you want to console.log something, it's sometimes nice to pass in a string and then comma and then the actual variable itself. That way you have a little flag in your console to see. So now we see repositories. Um, if you have a lot of console.logs, passing in a string with the name of the thing that you're logging is convenient for seeing what everything is. Okay, so we console.log, we saw what the value of that data looks like. Now uh, should see the list of your GitHub. Yep. Okay. Now we're doing error handling. So when you interact with another server over the internet, like we're doing with Fetch, you always want to do error handling because the internet is unreliable and other servers could be down. Um, there's a lot of like other factors that you can't control, and so it's always good to make sure that you got the response back that you wanted. And if you don't, then you should handle the case where you don't get the data you thought you did or you wanted. So yeah, we're going to do some error handling here. So there's one last thing that we're going to chain onto the end. So we have fetch dot then, and then the very last one, we're going to do dot catch. And again, catch, same syntax. You pass in an arrow function, open up the arrow function, and in the body, you can do things. And uh, where here we add response, and here we have repositories. Here in the catch callback parameter, we're going to add error. So catch is another thing that's built into dot thens. So dot thens return something, and um, if something fails within one of these, like if an error happens, then you can put a catch at the very end of any dot thens. And in this code, it'll actually this code will run if an error occurs in your fetch or any dot thens. So any errors will what's called bubble up. They'll bubble up into this catch here. So we could just console.log the error. Um, I think we're going to do something else other than console log it, but chain a catch function to your fetch call to handle errors from the server so that the user would know what happened if your project section was empty. Okay. So we probably want to actually like, yeah, I'll say to do add error message to DOM. Okay. And to do add repositories. So the next step is we're returning our repositories to, or we're going to parse through this response or the repositories here, and we're going to create HTML elements out of them, and we're going to populate this project section with the data from this repositories variable. And then eventually, once we do that, I can also use a similar technique to show an error, display an error as an actual DOM value or DOM element, if that happens. Okay, so create a variable named projects section using DOM selection to select the project section by ID. Okay, so we're creating a variable that should be named project section. So const project section equals, and maybe I'll get some audience participation. Does anyone have any ideas of how I could I have this section right here, and I want to select this in my JavaScript. DOM selectors. So we're going to use oh, document dot. So anything that has to do with like interacting with your HTML, the kind of like parent object of all of that is called document. So this is how you interact with your HTML document, is you're using this document object that's a global variable in JavaScript. Document, and it has a bunch of selectors on it. So we're going to use get. There's a query selector. This is probably the most common way of selecting an element. You can select an element by ID. So you could go projects like that. Um, they want us to select it by ID. There's another method called, where am I? Document dot. So query selector is one, but another one is get element by ID. And I'm just going to use that one. So document dot get element by ID, and this does what it says it does. It gets an element, an HTML element by its ID. So your section for your projects should have an ID with a value of projects or whatever it should be projects, but whatever this ID is for your project section, we can now select that element by putting that ID into this document.get element by ID projects. Kind of similar to like in CSS, we can do like selectors for different elements. So we're selecting specific tags in your CSS. Here we're selecting an HTML tag in your JavaScript. This is how one way to do it. And when you do this, always verify that it worked. I'm going to console.log project section. And I'm going to do this fancy thing that I like to do. Or label it. If you don't console log the DOM element that you're trying to select, it's going to cause a bug in your code like every single time. The amount of times that I've helped a student who has been stuck for hours trying to figure out what's going wrong, and it's 99% of the time they have some mismatch between this, or like between the ID they put in here and between what's in here. Because what we're doing is there's context that's not available in our JavaScript file. And even if you're using AI to help, the AI might not see your HTML and it might not know, oh, I have an element. It might not know what elements you have and what they look like in your HTML. So this intersection between your JavaScript and HTML, this is like the biggest thing that goes wrong for people. And so every single time you do a DOM selector, you're trying to interact with an HTML element in your JavaScript, always console log to see if it shows up. So I'm console logging this variable here, project section. We should see that. Here it is. And I labeled it. So now we can see project section is this thing, section projects. And we can open, and you don't have to look at it. This is what a DOM element is, has all this crazy stuff on it. We don't need to worry about it. We just need to know, yes, we got the element. This is a DOM element. If you misspell this, like if I said project, if you misspell it, you'll see null, which means our document.get element by ID couldn't find an HTML element with that name. So I said project, it should be projects. And now we see it's right. So yeah, make sure to always console log your DOM elements. I can't stress that enough. Okay, we got project section. We use DOM selection to get the section by ID. Now we're going to create another variable called project list and use DOM selection query to query the project section to select the element. Someone needs to do like Grammarly over this. Okay. So we're selecting the project section, and what that next line is saying is We don't want the project section itself. We want the unordered list inside of it, the project list. But I don't have a project list, so I need to make one in my actual HTML. I need to make an unordered list element. Make sure to have that. And we're going to select this unordered list now. And since we've already selected this project section, it'll make it easier to select this unordered list. If we had a bunch of unordered lists, which I actually do have one up here, unless you add like IDs to them or something, it's nice to be able to like, there's a bunch of different ways to select things. And if you select the parent, then you can select the child of any element more easily. So we have this project section, and now we can select the unordered list inside of it by doing this. So project section we got. Now I need to get the unordered list. So const projects list equals, and it's saying query the project section instead of the entire document to select the element. What that means is here, where I have document.getElement by ID, we're selecting out of the whole document. Here, I'm actually going to use the project section, which again is that parent section element. I'm going to use this section, and this every DOM element, every HTML element has all these same selectors on it. So you can like recursively select any element you need. So instead of get element by ID, I'm going to do project section dot, let's do query selector. Query selector does the job of get element by ID, except it can get an element by tag name or class or ID or anything. So I'm going to get, if, and the syntax for that would be if I did, just like in CSS for a selector, if you do a pound, that would get it by ID. If you did a dot, that would get it by class name. If it doesn't have either of them, then that's getting by the actual tag, the type of tag. So we're going to the project section, which is this right here, this section. We want to select this unordered list. So we're going project section, and then we're selecting the unordered list tag inside of there. And I'm going to console log that out to make sure that that worked. Yep, here it is. And again, we're seeing repositories at the very bottom, or actually, that console log is at the very bottom. But we could move this to the top. We moved all that fetch stuff to the top. We'd still see the console log of repositories at the bottom because it's waiting until we get the response from the server. I'm gonna undo that. Okay. So we have our project section. We have our project list. We console logged. Make sure to console log and verify that you're selecting these elements. Now let's create a for loop to iterate over our repositories array. So the repositories array, that's from the code we wrote earlier for like inside the fetch. So there's kind of two different parts of our code here. This is DOM selectors. So like we're getting HTML elements. And then this part down here, which we wrote at the beginning, this is fetch. Getting projects from GitHub API. So those are kind of the two main things that we're doing in our code here. And now we're going to tie them together. And if you remember when I got this repositories thing, I said to do add repositories to DOM. Well, now that we have the projects list in a variable, which is this unordered list right here in our HTML, we can take this and populate it with data from this GitHub response, the repositories. if if I didn't do these DOM selectors up here, we wouldn't have fine-grained control over where we put elements. So we want to select the elements that are like, you can only put an element in JavaScript, you can only put an element somewhere in reference to another element. So we have to grab the elements that we want to put elements inside of or above or below. So we grab this project list element, this unordered list, and what goes in an unordered list? LIs, like that. So we're going to just have a bunch of these, and they're going to have our projects in it. But we're going to add these through our JavaScript. Don't write those in your code. We're doing it in JavaScript. So the JavaScript is going to go get the projects and fill this unordered list with list items, which are those LIs. So we're going to take this project list and we're going to bring it down here into our .then with repositories, because we want this repositories variable and we want to iterate over this. And actually, I'll keep the console log because we want to remember what this looked like. Repositories looked like this. It's a big giant array. In my case, it has 30 projects. In your case, it'll probably have like one or two. But each element in this array is an object with our project, with information about one of our GitHub projects. And it's coming straight from GitHub server. So in order to actually take each of those projects one at a time and add those to our HTML, we want to do a loop through the repositories array. Like if I did type of repositories, hello, type of repositories. Oh, I need to console log that. Whoops. Oh, it's an object. It's because JavaScript is weird. I'd have to do array.isArray, actually. Array.isArray. So technically in JavaScript, an array is an object. So the way to check if something's an array is to do array.isArray, which is annoying, but yeah. So true. That means this is an array. We knew that. I told you that already. So because this is an array, we need to loop through it. So we're going to loop through repositories array and add, I guess, like get specific project data out. Maybe I'll make this into like a list. Get specific project data out and create DOM elements, which, remember, when you see DOM, you should think HTML. DOM, the document object model, is just the representation of your HTML in JavaScript. So HTML equals DOM, DOM equals HTML. And then we're going to add the DOM elements to your page. So just creating the elements is not enough. We need to add them into the page. And we're going to add them into the project list. That's why we selected that. So this is kind of our pseudocode here. But let me go back and make sure I'm doing this according to the instructions. So create a loop to iterate over your repositories array starting at index 0. Okay. We've done this before. We're going to do a for loop. For let I equals 0. So a for loop takes 3 expressions. You declare the iterator. You loop for as long as this expression exists. So we're going to loop for as long as I is less than repositories.length. So that will mean this loop will go all the way up until the very last element of repositories. And for each iteration, we're going to increment I by 1. Okay, there's our for loop. It's the same syntax for every array, pretty much. Anytime you're iterating over an array, you're pretty much going to use this same syntax, which is declare your iterator at 0. If you want to loop from 0, we could loop backwards if we wanted, which would mean changing up a couple of these things, but we're looping forwards like normal. Okay, so now this code will run a bunch of times. I could console log I. Oh, wait, I. And there we go. So we're seeing I is getting incremented up to 29 from 0. That's 30 times, which is the same length of this repositories array. But because arrays are 0 indexed, the first element is actually 0. So it only goes up to 29, even though that's 30 elements. So we're going to get some specific data out of this in the loop. Create a variable named project and make a new list item element using the create element method. Okay. Const project equals, did it tell us? Create a variable named project and make a new list. I think they forgot to tell us that project should be repositories at I. So I is going to increment. This code is going to run over and over, right? And each time I is going to be the next index in the array. So project is going to get created over and over and over with each project that is in this repositories array. So we're creating that and then make a new list item element using the create element method. So we're going to create a new DOM element that's a list item. And I'm just going to call it li equals document.create element. So document.create element is how you create a new DOM element in your JavaScript. And then you pass in the type of element you want to create as a string. So li. I want to create an li element. Okay. So, and let's just to kind of align this pseudocode back up. We're looping through the repositories array. We're getting a specific project out right here. We're creating a DOM element. And now the last step is we want to add the DOM element to our page. So on the next line, set the inner text of your project variable to the current array elements name property. Oh, this is where they're actually using the index to get the specific thing. The inner text of your project variable. Oh, so they wanted us to create an empty project variable. It's kind of dumb. Sure. I'll do it their way. So they want us to go let project equals nothing. And then down here, assign project to repositories at I. Sure. No, I don't like it. I don't like it. I don't think anyone's going to give you a hard time if you do this. This is the more straightforward way of doing it. The only difference is they were having you declare it as nothing and then assign it to this on a different line. But I think it makes more sense to just declare it and assign it to the value because we already have this. And using const is better if you can. Otherwise, we have a mutable variable and we might accidentally mess it up. Okay. On the next line, append the project element to the project list element using append child. Oh, wait, I forgot to set the inner text of my project variable to the current array elements name property. Now I guess I see why, yeah. So they want us to do this. Repositories at I.name, which is kind of confusing, but it's fine. Um, so what we're doing is repository.I. Remember, repositories is an array of projects, and each project, it's right here. Each project in this array is an object, and each object here, which you wouldn't be expected to know this, but you can actually look. We can scroll and we can find these are like this is information given to us from GitHub. They decided to give this to us. So one of the things that it gave back is the name. So I have a project called 100 Days of Code. And no, I didn't do 100 days of code. It's a challenge. You try to write code for 100 days. I got to day like 2. It's okay. It's okay to have a life outside of coding. Um, okay, so we're getting that name property out. That's what we're doing here. So we're indexing the array to get a specific object, and then we're getting the name property of that object all in one. So now, before project was this variable here was being assigned to an object, and now it's being assigned to just that string. That's the name of each object. So each loop iteration project will be the actual name of the project. And then this li here, there's actually one more step. Put the data from the project into the DOM element that we created, the li. So this list element here, we can actually use a method on it called inner text and assign it to project. So project is the project that has, or it's the current project, it's the name of it. And then we're going to assign the inner text of the li element we just created to the name of the project. So now this will be an li that looks like this. Look um, like that. And I could actually put this in my HTML so you can see like that. This is what it's going to look like. But the last step, so we have this variable that looks like that, but we don't have it in the DOM yet. So when you create an element, it doesn't exist in the DOM. It just it makes an element that you can store in a variable in JavaScript. Now we need to actually, we've added our name inside that DOM element. So we're kind of like preparing this li to go into our actual page now. And now we're going to add it to the page by doing projects list dot append child, which means if there's any children elements inside projects list, put it at the end. That's append. This is the most common method to use when you're adding list items into something. So projects list dot append child, not projects list, li. So the projects list, that's that UL right here, right? And then we just made LIs, list items, added, put the inner text of that li to be the project we got back from GitHub, the name. And now we're actually, so we take the existing element and put the newly created element inside the one that's already in the DOM. And now the DOM will actually get populated with that new element. And let's check. Yep, there it is. And it looks bad. These are unstyled elements, so they just are going to look bad. And you might think you're doing something wrong because it looks bad, but that's actually correct. This is what you want. Uh, we could bring in some CSS and make it look better. But these are the projects. So we've iterated through each project, gotten the name out, created an li element. I could actually look, go to my dev tools here. My projects has a UL, and now there's LIs from my projects. Cool. So we're almost done. Um, save and refresh your browser. Okay, I don't have to do that because I have live server set up, which updates automatically. List of your repositories beneath the projects heading on your portfolio site. So my projects, and yep, there's my projects. And now they want us to style it. Open your index.css, add styling to your projects list. Be sure to account for any changes you want in media queries. Stretch goal is to use Flexbox. So I think I do have, I had a way that I was styling these. I kind of have a lot going on in my CSS, but don't worry about it. I'll really quick just show you how I would style these. What I would do is, first of all, I would make sure that I can see my web page while I'm writing this code, because when you're doing CSS, when you're doing pretty much any code, you should always be checking to see what you're actually doing. Because at the end of the day, we're making a website and we want to see what it looks like. So I'm going to go to my index.css now, and I'm going to do some styling. So we know we have a project section. And just to verify, this is kind of like the console.log. It's the equivalent where I'm going to just do like a sanity check. I'm going to switch the background color to red just to make sure we're selecting projects correctly. So looks bad, but we can see now. Okay, we got this selector right. If I had forgotten that hashtag, now it's wrong because we're expecting something to be red and we're not seeing anything red. So I know this is right now. Okay, so we got projects, we got the section. Now we can, we don't actually want the project section because the section is right here. What I want is this UL inside, the unordered list. So I can do projects, and then the way to do that is UL. And you can hover over it, and that'll show you any element with an ID of projects, any number of elements as that are children of it, and then a UL. So it's selecting the UL that is any number of elements, like it doesn't have to be the direct child. It could be a child of a child of a child, but it needs to have an element with an ID of projects. That's so when you hover over one of these, that's what it's showing you. So this should be the UL that we want. And so I can verify that by doing a background color again. Yep. And I can make it a flex box if I want, or a grid. Um, let's make it a flex box. Display flex. Looks terrible. Lines them up all side to side and stuff. Um, I'm going to make this have a max width of, I guess, like 100 view width. It probably already does. But not doing anything. Why is it extending so far? Oh, I probably need to do wrap. Uh, flex. Sorry, this little window appearing here gets in the way. Flex wrap. Yes, true. Right? No. Pretty sure. Oh, flex wrap wrap. That's what it is. Okay. So now it's wrapping, so it's not going to extend. It's going to wrap instead. And then I can add a gap in between everything. Do gap. I'll do one rem. Um, Starting to look better. Now, maybe I'll do a margin on the top because this list item is pushed up next to my projects, and I don't like that. Uh, so I'm going to do margin top, 2 rem maybe. Looking better. And then each of these list items, this is going to be what actually makes it look better. I'm going to select any li inside of the projects. And I'm going to say um, background color is going to be, and something I kind of like to do, I pick a random thing and then I just make it like a gray and then I lower the opacity, or like a black. And then black or white increases if it's lighting the background up, or so I'm just adding like transparency to this color here. Um, I'm gonna have each of these get a little brighter. And actually I do think I'll have it be like a blue. And I have a color picker too. I have one called Color Slurp. I have another one called, I have this thing called Raycast, which is an app that allows you to do a bunch of cool stuff. So I'm just selecting that color. It's the actual background, and I'm just going to lighten it a bit. I'm going to add padding to each element. I'm going to add a border and a border radius. So border, um, 1 pixel solid, and I guess I'll do that color and then just make it a little darker. And then I can do a border radius, maybe 0.5 rem, maybe 1 rem. Yeah, sure. Okay, so that's looking a little better. So, um, and I could actually, if I wanted, I could make them appear like they're left aligned right now, but I could do justify content center, which would center align them. And that has to go on the parent that has the flex box on it. Looks cool. And then maybe one last thing for just some extra zhuzh. I'll go to the projects li and do a hover, and I'll do like a couple hover effects. So I'll add so this is called a pseudo selector, the colon, and then you can do like hover or focus, or there's like these different things you can do it's the same element, but it's a different state of the element. So when you hover over it, you can add different properties. So I'm going to do a shadow. I'm going to do a box shadow. And for this one, I could get help from Copilot. Yeah. Yeah. Oh, completions. There it is. There we go. Certain things, well, I would normally code with Copilot on all the time, but when I'm doing a lesson, I feel like it's better but shadows are kind of the syntax, or is like, you don't really have to bother ever learning the syntax for some of these CSS things. If you really want to do shadows, you can search CSS box shadow generator, and there'll be websites that allow you to mess with all the different things and get the right kind of shadow you're looking for. And then copy the code. Where is it? Here it is. There it is. And the nice thing about using these generators, like just find a website that does it. And you can find those for a lot of different CSS things, by the way. But they'll give you the WebKit version and the Mozilla box or the Mozilla version. So different web browsers and different things have different levels of support because your HTML, CSS, and JavaScript are all enabled by the specific browser that you use. So if you're on like Chrome, it might look a little different than if you're on Firefox, than if you're on your phone or like different ways to view the web page. And so the WebKit, this makes it so that it works better in um, different devices like that don't normally support the box shadow or something. So anyways, now when you hover over it, it has this terrible shadow. Let's go back to the one that Copilot gave me. Yeah, that's better. I could do a cursor pointer. So now my cursor turns into a pointer when I hover over it. It even, this is another trick on hover. I can make um, I could make a BG filter or drop. Wait, what is it? I'll just change the background color. Changing the background color to be a little lighter. Yeah. Just ways to make your website look a little better. And I can do a transition. So yeah, transition all 0.3. So now it's kind of smooth. Might be hard to see on over the recording or over Zoom, but anyways, I like CSS a lot. I could get carried away. So before I do, I'm gonna just wrap it up. Um, how's everyone feeling? Any like thoughts, questions, comments? It's making sense.
Yeah, it's making a lot more sense. Thank you for showing like the whole process and explaining everything. Also, the list, you made it look really good in a matter of like 5 minutes or less. That was really cool. I got some inspiration for my website.
Cool. I'm glad. Yeah. I really like CSS. A lot of people hate it, but like I immediately gravitated towards it when I started learning to code. So I always, yeah, do stuff like that. My biggest hint for CSS, my biggest tip is use border radiuses. Make because this is how you get a rounded border on elements. So take an element, put a background color on it, put a border radius on it, and it'll just immediately look better. Not everything. I mean, don't you can definitely go like too far overboard. And some websites look great without any like rounded borders, but I do think they look good. So, oh, looks like I have some chat. Document.query selector. Yes. Sorry, a bit late on that one. Um, everything's so clear. I have to leave. Oh, okay. There'll be a recording. So, and I'll let everyone know in Slack. I'll make a post about it. A lot of things are clear. Cool. Happy to help. Um, yeah. Okay. So any last questions before I wrap up? And yeah, I'll put the recording up. So if anyone has any, you know, they're doing this and they forgot how I did something, they should be able to check back at the recording. I'll do like I'm glad I added these comments because now you can, oh, I forgot to add the error message. I'll add the error message really quick. So we have this dot catch. So we just want to add an error message to the DOM if there's an error. So I could say, oh, and I have Copilot helping me. Sweet. Okay. Creating an error message using document.create element. I'm going to create a paragraph tag for it, set the inner text to the error.message. And now we need to add this into the DOM somewhere, which we could just add it into the projects list, I think. Oh, class. Yeah, we don't need that, but yeah, project section. Probably better than adding it into the actual list. Um, Here, Copilot suggested I add a class to this new element, this p tag. This is how you do it in JavaScript if you want to add a class. And a class can be used to make something easily selected by CSS. So it's adding a class called error. And now if I go into the reason it's doing it that way is because it's nice to, it's pretty standard. If you want to do something like that, you could do it like that. You make a class called error, and this is what's called a utility class. So it's not referring to a specific element. It's referring to any element that happens to have this class. So now you can add error to any class and it'll always get the color of red. And now if I get an error, which, let's see, how could I make it error out? I know how I can make it error out. There we go. This is not valid JavaScript, in case you were wondering right here. But because we have this catch here, any error, including this horrible syntax error, is just going to bubble up and get caught by this catch, and we can handle it. So now we're seeing that error showing up in here. That is not defined. But in reality, what we would expect is if the GitHub server was down or something, it would return an error and then we could display it to the user. So that's adding the actual error to the DOM. Okay. Oh, wait. This is my reference. Here it is. Okay. I'm going to say bye. Good job today, everyone. I know that was a lot to sit through. Um, and yeah, appreciate you guys all being here. And I'll be around. Hit me up on Slack if you need any extra help. Okay,
Thank you.
bye.